Alright, Coach Osborne here with page 2 of your Unit 6 review. Okay, so now I'm going to start with this first problem, number 7. It says solve for y and state the slope and y-intercept. Well, if it says state the slope and y-intercept, that means that we're going to have an equation that's a y equals mx plus b type of equation. Okay, so let's go ahead and solve, remember, for y. So that's the one we want to get by itself, because you notice there's an x, so we're not going to find one number, we're going to find an equation. Okay, so let's simplify. First, we're going to distribute there, that 3. Negative 3 times y is negative 3y. Negative 3 times negative 2 is positive 6. Okay, so now again, I've got the y over here. I want to get that by itself, so I want to move these two terms over to the other side. So let's do that one at a time. So first I'm going to move the number and subtract that from the 3. But I can also move the 7x at the same time. That's a positive 7x, so I'll subtract that. And I can subtract that from the, remember this is a 1. Okay, so that's gone. So now I have negative 3y is equal to 1 minus 7x, or 1x minus 7x, that's negative 6x. And the negative 3 minus 6 is negative 9. Okay? So now the last step to get y by itself, just like the page before, is divide that number next to y. That becomes 1. And divide the negative 3 everywhere. So now negative 6 divided by negative 3 is positive 2x. Negative 9 divided by negative 3 is positive 3. So there's the new equation. Okay, so we'll write that in here. The slope, again, is the first number. Right next to x, there's your slope. Okay, and then your y-intercept is the last number. That's your b. Okay? Okay, so now the next one, it's asking us to solve for x, and if I notice that there's only x in this problem, so that means we're actually going to end up with one number at the end. Okay, so let's go ahead and simplify. So 4 times x and 4 times 3. Well, if I'm multiplying two x terms, x times x becomes x squared. Okay, so then 4 times x is 4x squared. 4x times 3 is just 12x. Okay, now here I've got two numbers times two numbers, so that I've got to multiply with the box. So x1, 4x and minus 7. So x times 4x, again 4x squared. 1 times 4x is 4x. Then up here it's x times negative 7, so negative 7x, and then here 1 times minus 7 is negative 7. So on this side, I'm going to add up all these terms inside. So 4x squared goes first, and now the like terms are 4x minus 7x, which is negative 3x, and then I have minus 7. Okay, so now right away I notice that I've got a positive 4x squared and another positive 4x squared. So if I subtract those from both sides, those are going to cancel. So let's rewrite the step. Go to the next step. So I still have the negative 3x and the minus 7. Now, again, I want to get x by itself. I already have an x by itself over here, so let's move all the x's to the left. Let's add this 3x to get rid of it, and then add it to the other side. So I get 15x is equal to minus 7. Okay, the last step here is divide by the 15. The number next to x, that becomes 1, and then I end up with a fraction. So I have negative 7 over 15. So sometimes you do end up with a fraction. Okay. Now, given this sequence, what kind of sequence is it? So now we're getting into a little review of the past, the arithmetic, geometric, and neither. Remember, arithmetic is if we're adding and subtracting. Geometric is if we're multiplying or dividing. And then neither is like basically something that's not constant. Okay. Well, I notice from here to here, the difference is 300. Then from here to here, the difference is 150, and then from here to here, the difference is 75. So it's going down, but it's not subtracting, because it would have to be subtracting the same number. Okay, so what you could do is you could take this number and divide it by the next one. So 600 divided by 300, well, that's 2. And then I take the next number divided by the number after that, 300 divided by 150, that's also 2. So what's happening here is we're dividing by 2. Okay? So this is going to be a geometric sequence. So you're dividing by 2, or remember, it's the same thing if you multiply 1/2. Okay, now write an explicit equation for the sequence. Okay, so to find any term in this sequence, okay, we're going to write an equation. Basically, this a sub n represents the term. Okay, then we're going to put the starting number, like our very first number. Okay, so our very first number we can call a sub 0 or t sub 0, or whatever you want to call it. Okay, times, because we're multiplying something, okay, times our multiplier. And now in this case, you multiply 1/2. You're dividing a 2, so we're going to do multiplying 1/2. Okay, and then we're going to raise that to the term number. Okay, so the way we write this out basically is that, and we could actually put t of n t sub 0 times 1/2 to the n. That's another way of writing it, because you guys have seen t of n before. Okay, so t of n, let's do t of n, equals the first number, 600, times, okay, the 1/2, raised to whatever number you're looking for, or whatever term you're looking for. So if I'm looking for the term number 1, okay, I would plug in, or term sub 0, this first term, I would just plug in 0. If I'm looking for the next one, I plug in 1. If I'm looking for the one after that, it's 2. Okay. Okay, so now an item costing $35 is increasing 4% each year. Okay, create an equation to model the situation. So this is pretty similar. So we're still going to use that same model of this equation. Okay, so we're going to say t sub n, okay, starts at $35, and now remember that we want to convert this to a decimal, so 0.04. Okay, but then we're actually not just multiplying 4%, we're multiplying 100% of this plus that 4%. So the multiplier is going to be 1 plus that, okay, raised to the amount of time. Raised to the amount of time. So really the equation looks like this. A is equal to P, which is your first number, times 1 plus, or minus if it's going down, your rate. Okay, and the rate in this case is the 4. Okay, your P is the 35, and then raised to the amount of time that's passed by. Okay, so how much will the item cost in 6 years? Well, I'm just going to write out this equation. So equals 35. It's going to be equal to 35 times, actually this should be an n here. So let's do this a little different. The t sub n. Let's do, we're talking about cost, so we'll just do like a big C. C of t, like that. Okay, because that has to be the same as that. Alright, so now 1.04 raised to the amount of years, the t, the time. Okay, so in a calculator, the way we do that is 35. I'm going to just write it the exact same way, parentheses, which means 35 times 1.04 raised to the 6. Okay, so we get, now remember this is money, so we're going to round to the nearest cent, $44.20. Well, there's a 6 there, so that's going to move the 8 up to 9. So equal to $44.29. Okay. Okay, the other way to think about this is if I had a table and I started with $35 at 0, okay, after 1 year I would multiply 1.04 and I would get, let's see, what is that? 35 times 1.04 is 36.4, and then I'm going to multiply 1.04 again. and again, and again, and again, and again, until I get to that same value. Okay, so I just basically multiplied it 6 times. That's why we raised it to the 6th power. Okay. All right, so now back to solving systems. Saying solve the system to state the solution. Okay, some of you guys might already recognize what's going on here. I'm going to add these two because I have same numbers here. Actually, both the x and the y are same numbers, and they're opposite. So I'm going to add them, and then add this side as well. So 4x plus negative 4x, that's gone. That's a 0. Negative 5y plus 5y, that's gone. That's 0. So this whole side is equal to 0. And then 11 plus minus 11, or 11 minus 11, is also 0. Now, if you get a solution where both numbers are equal, this is not a no solution. This is actually all real numbers. Or infinite solutions. That's another way of saying it. I know some of you guys use that word. Okay. All right, so now the next one, create a system of equations based on the situation. Now notice what it says, create a system of equations. It doesn't say solve it, so literally you just need to create a system of equations in this case, okay? So at Sprouts, they charge $4 a pound, $4 per pound, so that's probably 4 apples. Okay, so I'm already thinking $4 times the amount of apples, 4A. Okay, so I don't know how I'm going to use that yet. And $3 per pound for oranges. So $3 per pound for the oranges. Okay, so 3 times O. Okay. And be careful, don't make that look like a 30. Actually, I don't really like that one. Oops. Okay, so $3 and then O, and we'll do a little tiny O. Okay. Alright, so I bought 18 pieces of fruit and spent 28 bucks. Okay, so there's a system. So first let's talk about the pieces of fruit. Okay, well, the amount of apples, the pounds of apples, I don't like this question because pieces and pounds are not really related. Because you could have like 4 apples, but then that weighs only like 2 pounds. Okay, so what we're going to do is I want you guys to change from pieces and change this to pounds. Okay? Alright, so 18 pounds. So we bought 18 pounds of fruit and spent $28. Okay, so this is going to make a lot more sense. So now A, we're going to say, represents the pounds of apples. And O is equal to pounds of oranges. Okay? Alright, so let's start first. Let's talk about the pounds equation. Now, this last sentence is talking about the total. So 18 pounds total, and then $28 total. So we got a pounds equation, and then we have a money equation. So first let's look at pounds. Okay, so the pounds of apples plus the pounds of oranges is equal to 18 pounds. Alright, that one's simple. The next one is the money spent was $4 per pound, so $4 times the pounds of apples plus $3 times the pounds of oranges. I know that looks like a 30, but trust me, it's an O, okay? I probably wouldn't have chosen oranges. I would have done like bananas or something, just so that there's no confusion. Or dragon fruit, I don't know. Okay, anyways. Okay, so that pounds of apples times the $4 per pound, and then pounds of oranges times $3 per pound, that equals our total amount of money spent. So there's our total. Okay? Alright, so now the last problem here. Okay, George is growing cherry trees. Alright, so we got another word problem. We're going to have to create an equation, so we need to look for the information. Here's our question. 2 questions, and then we are going to have to create a graph and circle the point of intersection. So we have to do a few things here. Alright, so he's growing trees. His Morello trees are 7 feet tall when he plants them, and they grow 1 foot per month. Okay, his Bing cherry tree starts at 3 feet tall and grows 2 feet per month. Well, the situations are, we have a Morello tree and a Bing cherry tree. So those are our 2 different equations right there. It's 2 different situations. So this is a little different than some of the other situations. we've got like a starting point because it starts at 7 feet tall and then grows 1 foot per month. Okay, and then here the other tree starts at 3 feet tall and grows 2 feet per month. So this is going to be a y equals mx plus b type of equations. Okay, so the first one, well, it's going to be y is equal to the growth, which is 1 foot per month, so it's going to be positive 1x plus where it started, 7. Okay, now this one is going to be just like that, so it's y equals 2x, 2 feet per month, plus where it started at 3. Okay, so when will the trees be the same height? Well, we have to solve that. Okay, we're going to graph the equations to find that circle, that point of intersection. So when you guys take this test, I'll make sure that you guys have grid lines and actually can see the graph. Okay, so let's start off with this one here. What I'm going to do is kind of draw on some lines here so that I know where I'm going. 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Just had to do that to make sure that everything lines up. Okay. All right. So first, the first equation, that's 7. Now, again, we need to know what x represents and what does y represent in this case, because we need to know how tall they will be and when they'll be that tall. Okay, so we can do that by looking at let's first look at the starting point. The starting point is always on the y-axis, so that means that this is feet. And the other factor we're talking about is what the time. Okay, so months. So x represents months. Okay, and usually x is always going to be the time factor anyways. Okay, oops, sorry, something's trying to call me here. All right, so the first equation we start at 7, so right there. Okay, then the slope is 1, so up 1 over 1, so up 1 over 1, up 1 over 1, up 1 over 1. I kind of have to be careful here. Okay, up 1 over 1, so I'm going to line it up. So up 1 over 1. Okay, so I'm going to just kind of hope that it lines up somewhere here. I could continue the lines, it's just I can't see the points, so I'm going to try to do that. Let's see, 1, 2, 3, 4, 5. Actually, 5 is right there. Okay, so now the next one, 3. I'm going to start at 3. Okay, we're going to go up 2 over 1. So up 2 over 1. Okay. To 5, up 2 to 7, then over 1. Okay, up 2 from 7 to 9, and then over 1. Okay, then up 2 from 9 to 11, then over 1. There's our solution. Okay, that's what we were looking for. So what I'm going to do now is I'm going to actually draw out my lines. So I'm going to start it there, and then I'll go off in this direction. Okay, so this tree is the Bing. I'm going to label it. Okay, the next one is going to be the Morello tree. Okay, so that goes there. Okay, so now, again, I need to know that point. And on the graph, it's going to be a lot clearer. So here it's at 4 months and 11. That's 4, 11. So 4 months and 11 feet tall. When will the trees be the same height? At 4 months. Okay, and how tall will they be? They'll be 11 feet. Okay? All right, that's it.